Hello everybody. We are going to be going through the second section of Unit 5, which is sigma notation. It's talking about series, which is a little bit different than sequences, but that's okay. We'll explain exactly what it is. Sometimes it's necessary to find the sum of the first however many terms of a sequence. The sum of these terms is called a series. Such a sum can be represented in a compact form called a summation, or sigma notation, and that is that fancy backwards looking E thing, sigma, and it's used to represent a sum. So a sequence is when the numbers are ordered in a specific way. A series is when you're adding them all together. So if you were to read this summation right here, that would read the sum of, the sum from 1 to 4 of 4n. So that bottom number down here is where you're starting, and this top number up here is where you're stopping. So to write the terms in this sum, you're going to plug in each whole number, and I'm going to abbreviate here, starting with the n equals, going through the top number. So if we were to do this, we can do the exact same, almost the exact same thing that we did with sequences. So we're going from 1, 2, 3 to 4. And we're just going to plug in our numbers. So we have 4 times 1, which is 4. We have 4 times 2, which is 8. We have 4 times 3, which is 12. And we have 4 times 4, which is 16. The difference is now, instead of just leaving them in a sequence like that, a series puts plus signs in between them. So 4 plus 8 plus 12 plus 16 actually gives us 40, which is what our answer would be. So the sum from 1 to 4 of 4n is 40. We're going to do a couple more examples here. So the second example, this one is the sum from 2 to 4 of I squared times x to the I power. So we're going to start again. We're doing just 2, 3, and 4 this time because we're starting with 2 and we're going through 4. So 2 is going to be 2 to the second power times x to the second power. The reason we have that x in there still is because our variable here we're talking about is I in this case. So 2 to the second power is 4, so this ends up being 4x squared. For 3, it's going to be 3 to the second power times x to the third power, because our I is 3 this time. So that ends up being 9x to the third. And the last one is going to be 4 to the second power times x to the fourth. So that's 16x to the fourth. You can't combine any of those because they're not like terms. You have x squared, x to the third, and x to the fourth. So you're just going to put plus signs in between them, and that is your summation. And the reason we use this notation up here, that is not an arrow, this notation up here is because it's a lot simpler than writing out this whole thing down here. Last example for this section. It's a little tricky. This one looks really complicated. It ends up being not so difficult though. So we're going from 1 to 2 to 3 to 4. Again, we're starting at 1, going through 4, and our variable in this case is m. So we're going to have negative 1 to the 1 plus 1. And then over here, we're going to have 1 squared plus 2 times 1. So this is going to be negative 1 squared times 1 squared is 1. 2 times 1 is 2. So negative 1 squared times 3, which gives us a positive 3. Oh, that's the phone. We'll answer it in a minute. So we'll have negative 1 for the second term to the 2 plus 1. And then we're going to have 2 squared plus 2 times 2. So this is negative 1 to the third power times 2 squared is 4 plus 2 times 2 is 4, so times 8. That's going to be a negative 8. For 3, doing the same thing, we have negative 1 to the 3 plus 1 times 3 squared plus 2 times 3. So negative 1 to the fourth power times 9 plus 2 times 3 is 6. So this is going to be negative 1 to the fourth is a positive 1 times 15, which is just 15. And the fourth one there is going to be negative 1 to the 4 plus 1 times 4 squared plus 2 times 4. So this ends up being negative 1 to the fifth times 4 squared is 16. 2 times 4 is 8. That ends up being 24. So negative 1 times 24 is negative 24. Now when you add these up, this is a bit of a trickier addition because we're putting pluses in between them. You're adding 3 plus negative 8 plus 15 plus negative 24. So you're going to get something that's not going up the whole time. These negatives here are actually almost like subtraction. So you'll end up with the sum of this is going to equal negative 14. Oh, I don't know why I wrote that. That's not correct at all. 3 and negative 8 is negative 5. No, that is right. Negative 14. I was thinking this was a positive for some reason, but it's not. It's a negative. We're going to skip the section at the top of the next page that's talking about the calculator, because I know most of you don't have calculators at school, or at home. We only have them at school, so we'll talk about that a little more tomorrow if someone reminds me. We are, however, going to write each of these in summation notation. So we're looking at the series here, 1, 1/4, 1/9, 1/16. And like I said in class, you have to make sure you're looking at the whole picture of this, not just at one piece. If I wrote this first one as 1 over 1, you need to figure out in terms of a sequence of numbers. So in terms of 1, 2, 3, and 4, how could I write this out? Well, if we have terms 1, 2, 3, and 4, this would actually be 1 over 1 squared. This would be 1 over 2 squared, 1 over 3 squared, and 1 over 4 squared. So if we're looking to write a formula for this, you're going to have to do the fancy summation thing. We're starting at our first term. We'll use x. So x equals 1 is our first term. And we're going all the way through. That's our first term. We're going all the way through 4. So 4 goes on the top. Now you need to write the formula for this. So the formula for this would be 1 over, well, 1 goes with 1. 2 goes with 2. 3 goes with 3. And 4 goes with 4. So this is actually going to be 1 over x squared. So the sum from 1 to 4 of 1 over x squared. And that, my friends, is your answer. These do get a bit trickier, so we're going to do 2 more examples here. You'll do a couple more in class. So if we want to write the summation of this next one, 4, 8, 16, 32, 64. We need to figure out in terms of 1, 2, 3, 4, and 5, what exactly is going on here. Well, it just so happens that we know that 4 is 2 squared, and we know that 8 is 2 to the third power, correct? So this could be your table right here, 1, 2, 3, 4, 5. We have 2 squared, 2 to the third. Guess what 2 to the fourth is? If you're smart, you know that it's 16. 2 to the fifth power is going to be 32, and 32 times 2, which is 2 to the sixth, gives us 64. So we're going to write our summation now. You use your fancy sigma notation. We're starting with, let's not use x this time, let's use m. M is going to be 1, and you're going all the way up through 5 this time. So the sum from 1 to 5 of 2, and you'll notice that 1 does not match 2 here, correct? So we have to do something. But you'll notice that 1 and 2 are 1 apart, 2 and 3, 3 and 4, 4 and 5, 5 and 6. So this is actually going to be 2 to the m plus 1. So the first term is going to be 2 to the second term is going to be 2 to the third term would be 2 to the fourth, and so on and so forth. So that one is a bit tricky. You need to be able to list out what you have going on right here and figure out how it relates to some sequence of numbers down here. Last example, by far the trickiest one of all. So I'm actually going to start out, I'm going to do 1, 2, 3, 4, and 5. And the very first thing I'm going to point out is that this is negative, positive, negative, positive, negative, and it would go positive, negative, and so forth. I think I stated in one of the other videos that this is called an alternating and in this case it's going to be a series, an alternating series, because you have positive, negative, positive, negative, positive, negative. So when you see one of those, you need to know that the first thing you're going to do is put a negative 1 and determine, are you starting with a positive or a negative? If you're starting with a positive, it has to be n minus 1. If you're starting with a negative, it can just be n. We'll use n this time. So n equals. And then we're going to multiply that by something else. So this piece right here makes our series an alternating series. So going back up to the top here, we need to figure out, well, we have 3 now, 6, 9, 12, and 15. And I'm hoping that you can see right away that 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So our alternating series is taken care of. We are starting at 1 and going through 5. And then we are going to have 3 times whatever number we're on, so 3n. So we now have an alternating series starting at 1 going through 5, so the sum from 1 to 5 of negative 1 to the nth power, that's the alternating part, of 3n, and that gives us all of our numbers over here. I know this is a little tricky. We're definitely going to practice this some more tomorrow, coming up with the formulas and all that. So if you need to, watch another section of this just to make sure you got it, and I will speak to you tomorrow. Have a wonderful evening.